Okay, this problem says the uniform boom shown below weighs 3000 newtons. So this weighs 3000 newtons, and that's its center of mass is where the weight acts. It is supported by a horizontal guy wire, so there's the horizontal wire, and by the hinge support at point A. So what are the forces on the boom due to the wire and due to the support at A? Does the force at A act along the boom? So since the boom is at an equilibrium, let's do all the forces. Okay, there's the tension, there's 2000 newtons there, and there's 3000 newtons in there. And let's say this is the reaction force that the hinge exerts on the boom. Okay. So what we need is, since the boom is at rest, okay, again, by default, we have our x and y axis like this. Sum of the forces acting on this boom should be 0, and sum of the torques of these forces should be 0. Okay. So let's look at the x components. Minus t plus rax should be 0. These other guys do not have a, this guy doesn't have an x component, this guy doesn't have an x component. Okay, and so the tension in the guy wire is equal to the x component of the hinge force. Okay, and let's look at the y components of the forces. The tension doesn't have any y components. This has a y component. Okay, so Ray minus 3000 minus 2000 equal to 0. So Ray equal to 5000 newtons. So we have the y components, but this is still undetermined. Okay, and the way we'll get that is from this torque equation. So now, and here's what we'll do. Since we don't know Rax, we'll eliminate that by calculating the torques about this point. Okay. Now, let's call the length of the boom as L. So the moment arm, this force will rotate the boom clockwise about that point, and the moment arm is L by 2 cosine 45. For this guy, there's the moment arm, and for this guy, this distance is the moment arm. Okay, so let's add a page. Okay, so let's do the sum of the torque equations. And again, like I said, we're calculating the torques about this point, and this is L by 2 cosine 45, this is L cosine 45, and this distance is L sine 45. All right, so clockwise torques are negative, so minus 3000 newtons divided by L by 2 cosine 45. Okay. Minus 2000 newtons L cosine 45. Okay. And plus tension L sine 45 equal to 0. Okay. Now sine 45 is equal to cosine 45. So all these terms drop off. Okay. So what we have is, and L is a common factor, so L drops off. So what we have is tension is equal to, this is 3000 by 2, so 1500 plus 2000 equal to 3500 newtons. Okay. So now that we have the tension, we have Rax as well. So and that's equal to Rax. Okay. So the reaction force is 3500 newton and Y is 5,000 Newton. So we have found the reaction force that the hinge exerts on the boom, and we also have the tension, which is 3,500 newtons. All right, so that solves that problem.